Hey guys, welcome to my channel. I'm Shahab and here's another episode of Inside Out about Roslyn, and in this episode we want to take a look into how we could change a syntax tree. So let's dig into it. Okay, here I have another console application, and in that application we have this piece of code that we want to see how the syntax tree of it looks like and how we could change it. Here's the problem. We have a couple of methods and some of them are returning something like the integer here. We don't want to touch the return value of those things. But for those methods that have void as a return type, we want to change it to be a task. So these three methods in here. And that's what we want to do. So we are going to get the syntax tree of the current source code, and then we want to change that syntax tree wherever there is a void return type to be a task return type. So let's see how we could achieve that. As always, the first things that we need to do is to add a reference to Microsoft.codeanalysis.c# NuGet package, and let's do that. So we have it in here, and I want to add it to change syntax tree, this one. We added that. As you could recall from the previous episode, there are two ways to get the syntax tree. One is through the C# syntax tree class and its parse text method, and the other one is through the syntax factory class, syntax factory dot parse syntax tree, and passing the code. So it doesn't matter which one of these approaches we are using, both will provide us with a C# syntax tree. So let's stick to the first one. I'm just commenting this later you could also have it. To see what would be the next step, I'm just copying this code in here to SharpLab, which was our code. It seems that I already have something in here. So if you see in this syntax tree, it starts with a compilation unit, which is a representative of the whole C# file, and then we have a class declaration. Within the class declaration, we have a couple of method declaration which are important for us. So we want to traverse this tree until we get a method declaration. Also, we have a nested class, which also have another method declaration. So we want to get this method declaration and these two in here. And that's what we want to do at the moment. So let's get back to the code. So to get all the method declarations, we need to first get the root of the tree, which is the compilation unit, and from there we want to say give us all the descendant nodes, as the autocomplete already did it for me, and we are interested in method declaration syntax. This is a C# class representing the method declaration syntax nodes in the tree, right? So this is what we are interested in, and I'm passing a lambda expression in here just to tell this method to traverse down all the nodes in the tree and give me all the method declarations, no matter where they are. After we have all the methods, what we want to do is we want to replace those method declarations in the original tree and get a new tree, right? So I'm going to say tree dot, syntax tree dot root dot replace nodes. This one, as you could see, it accepts an enumerable of t nodes, and which t nodes is like a syntax node. And then we have a function that is applying on those nodes and returning a new syntax node. This returned syntax node will replace the original one that we had in the other tree. So let's pass the methods in here, and then we have a function. It just autocompletes something. Let's say this is the original one. I don't need the second in here. And let's have the methods. What we want to do here is first we want to check what is the return type, right? So we are getting the return type from this original syntax node that we have in here. And then we want to check the return type dot get first node first token, let's go back to the tree and describe what we want to do. So if I hover over this method declaration, you will see that this method declaration has a return type in here, right? And that return type also has a void keyword, which is a token. And it is the first token or the only token in this syntax node. And what we want to do is we want to check whether our return type is a void or not. If it is a void, then we want to change it to something else. If it is not a void, then we want to skip this and return the original node in here, which would be this whole thing, right? So we don't change it and we just return whatever it is in there. So let's get back to the code. Here I'm getting the first node and I want to check its text, and if it is not a syntax factory dot token, and here we could pass a kind token, so I'm saying syntax kind dot void, then return the original one. Do not change anything if it is that. On the other hand, if it is a void, we want to change it. And what do we want to change it? I would like to have your attention on this part of the tree, right? See how it is changing when I am changing the code in the left side. I'm changing the void to task, right? And you see here, it has changed to an identifier name token. We have an identifier name token in here with task being its identifier, and this is an identifier name syntax node, right? So we want to generate this and replace it in the for our method. So let's say var identifier token, right? And then again, we are using the syntax factory dot identifier to create an identifier token, and I'm just saying it is a task, right? And then what we want to do is we want to create an identifier syntax node. So identifier name syntax node, and that would be again using syntax factory dot identifier name, and we are passing the identifier token that we created for that one. The last step is to replace the return type in this method that we are manipulating, like the original one, and returning this identifier syntax node instead of that. So let's say return original dot with return type and that one. And now you see there are like a warning in here, and it indicates that it is RS1014. It says syntax node is immutable and replace nodes will not have any effect on it. Consider using the return value from replace nodes. And what that means is that, as you might recall from the previous episode again, everything in Roslyn is immutable. So this replace node in here will not change the original one that we have in here, right? And also when we are changing the methods in this root, the original root, it is not changing anything there. So what we need to do is to define a new root in here and assign whatever is returning from this replace nodes to that as a new root, right? So now that we have our new root, we need to create a tree representing the new source codes. And this would be our syntax tree dot with root. And we are passing the new root and whatever options was in the syntax tree. At the end, we could just say console.writeLine and let's just pass the root. Every node in the syntax tree, you could pass it to the console.writeLine and its toString method will be called and prints out the C# code representing that part of the tree. So let's run our application. Cool. You see that the voids are replaced with a task, but there's a problem here. We don't have the spaces that we had before in these places, right? It should kind of be something like this space in here. And that's because we forgot to attach or move the trivias that were attached to the return type syntax node, and also the void keyword token, right? So let's take a look at where we could change that thing. Let's examine that first on the syntax tree that we have. If I select this void type in here, on the right side, you will see that this void keyword token has a space as a white space trivia attached to it. And when we are replacing this with a task, we need to also move this trivia. When we are creating our identifier token, what we could do is telling that we need some trivias. As you could see, here are different options. We have with trailing trivias, which are the trivias before the token. Then we have leading trivias, which are the trivias after the token. And we also have with trivia from, that we could pass another token and it just takes those trivias from this and attach it to this one. So here I'm going to say the return type dot get first token, which is our void token, as a token, and attach it there, right? And then let's just run the application again. And now you see that the spaces are back. There is also another way that you could attach trivias. If we want, we could say with trailing trivia, and then we say return type that get first token dot trailing trivia, and also another one for leading trivia. It should have the same effects as the previous one with leading trivia. It should be the same as the previous one. And if I run the application, you will see that it has the same effect. This is one way that we could change a syntax tree using the method chains that are provided. There are a lot of replace methods and with methods that you could play around. Depending on your requirements, you could use a different type of methods to change the syntax tree that you have. I hope you enjoyed this session. As always, enjoy coding and dametun gel.